Disappointingly enough, I am not a robot. I don't like doing the same thing, making breakfast every morning. And I can't afford to go to McDonald's every morning, and I don't have a wife. I'm stuck making my own breakfast every morning. Except if you haven't seen my last video, I have a couple robot arms that need a job. This video here will be more like a build video. If you want to see the final run, you can watch this video here. It'll also be linked at the end of the video. So this is my initial brainstorming model. The left robot needs this attachment, which gives it 2 extra degrees of freedom. Since most kitchen appliances are designed for humans to interact with them, I not only need the robot to move in XYZ, but also rotate around those axes to mimic a human movement. This is what the inside of the attachment looks like. Axis 5 is belt driven through a gear-ducted stepper motor, and homes with this limit switch over here that homes off of the housing of Axis 6. Axis 6 is designed to move fast. It's a direct drive stepper motor. The motor is placed in a way so it also counterbalances the payload to relieve some stress on Axis 5, and it homes by a limit switch that is looking at this difference in outer diameter by this clip that clips onto the actual motor shaft, and the software will only read a falling edge from this sensor, so it's always from the same spot. And all of the internal wiring will route through this hole here. So now that I have a general plan of what the robots need to do the job, let's put together the cell. My initial plan was great, except it sucked. There was a lot of details I didn't think through from the start, like the egg, which was the most painful part of this whole project. I didn't think about how you're actually going to grab it, how you're actually going to crack the egg, how you're going to dispose of the eggshells, how you're going to cook the egg, how you're going to take the egg out of the cooker, and do all this to a material that is a different shape, hardness, and weight for every run. My first ideas were to obviously use some sort of compliant mechanism to grab the egg, since every egg is a different size, but this proved to be too complicated when I could just use a simple fork mechanism by pressing these 2 rods into the small piece of aluminum extrusion and just kind of like fork it and roll it off to where it needs to be, which proved to be a much more simple, reliable solution. Now I need a way to grab this tool without it slipping or sliding and always being in the same spot on the manipulator. I could use some fancy tool changing equipment with pneumatics and all that fancy stuff, but the piece of the aluminum extrusion I use has a V-slot, which is mainly designed for V wheels so that you can have cheap, accurate linear motion because the wheel has the same profile as a slot and will always fall to the center of that slot, kind of like how a dovetail mechanism works. But here I decided to put some studs into the gripper that would sink to the center of the V slot so that the tool will always stay centered and the gripper has a good grip on it. Next was cracking the egg. Now this is a very complicated process. First thing I thought to do was to drill a hole all the way through the egg and let the egg drip out of the eggshell. So I spent all this time taking apart an old drill and fitting it to the robot, only to find out this was a very stupid idea and was not even going to come close to working. I looked around online for how other people solve this issue, and there were some very fancy robots that cracked an egg, much like we do, by hitting it off something and opening the egg. But I didn't find this to be very reliable, kind of too complicated for this kind of a project. And then I found this video where it shows off a tool that cracks an egg perfectly every time and separates the eggshells from the egg. And it worked for almost every egg I tried, no matter the size or strength of the eggshell. So now I just had to get a robot to use it. So I modified the handle by making one side flat so it'll fit to the side of an aluminum profile. Then use a servo motor to flip the mechanism to drop off the eggshells after it was done cracking. Then another servo motor to squeeze the handle by reeling in some string that went around the handle. But I continuously had problems with the string breaking and it wouldn't pull closed enough to crack most eggs, so I had to redesign the whole mechanism. In order to gain some rigidity, I got rid of the flipping mechanism and was going to find another way around that. I exchanged the string out for a lot stronger ribbon, got a servo that's a lot stronger and has a lot more travel to squeeze the handle all the way. And I had issues with the handle not always coming in centered, like the ribbon would pull it off at an angle and it wouldn't close properly. So I put this piece of aluminum profile to guide the handle in straight as the servo squeezed the handle. And I never had another problem with that again. Now, since I gave up the flipping mechanism, I had another problem as to how to get the eggshells out of the cracker once it was done with the egg. And sometimes we have crazy ideas, and sometimes they're just worth giving a shot. So I thought, what if we just threw it? So I left a lot of slack and backlash in the bolts holding on the egg cracker mechanism, Loctited the bolts down so they wouldn't back out, used some rubber bands to give it some elasticity, and now the robot can throw the eggshells into a bin. And this wasn't my first try. This is the process of me slowly learning how to tweak the mechanism and the program to get it to throw them reliably. Now the cooker. My initial idea was to use a waffle maker, that way it would cook both sides of the egg at the same time and I wouldn't have the need to flip it, but I didn't put any more thought into it after that, and I realized later down the road that a waffle maker was a horrible idea because it's nearly impossible to get the cooked egg out. It's difficult even for me to get the egg out, much less the robot. No matter how much cooking oil I sprayed, it wouldn't come out too easy. So I replaced it with a pancake cooker, which is flat, and it will cook both sides at the same time, and it worked much better. In fact, it worked so good that the first time I tried it, I simply just pushed the egg off the other side because it was so loose. So I added this piece onto Robot 2 that will keep the egg from pushing off the other side while Robot 1 grabs it. Now at this point in the program, Robot 1 with the 6 axes is busy holding the tool, so Robot 2 needs to open up the cooker lid. Now I don't have any sort of gripper or manipulator really on Robot 2, so in order to get by with what I had, I put these magnets on the handle of the cooker that the arm that grabs the fridge door grabs onto. This wasn't exactly reliable, but worked good enough to keep the project moving. The toast was an interesting one. All the robot had to do was put the toast in the toaster, put the toast down, see when the toast was done, and then grab it, and put it on a plate. First of all, the robot needs to see when the toast is done cooking. Instead of designing an elaborate sensor that sees if the handle's up, I found this sensor that just senses the current of a wire. And a toaster takes a lot of power to cook, so I put this sensor around the power wire wire of the toaster, and it sees if the toaster is done cooking by a drop in current. This input goes back to the robot arm system, and that's how it knows when the toast is done and it can grab it. Only as it's been grabbing it, I've had issues with most of the time the toast not popping up far enough for it to grab it, so I needed to find something that could handle the high temperatures of a toaster, be big enough to prop the toast high enough and not fall through the cracks to the bottom of the toaster, and also be small enough that it doesn't interfere with the closing walls that actually cook the toast. So the only thing I could find was this copper pipe, which is probably not food grade, but I don't plan on eating it. At this point, I just want to finish the project, but for the most part, it solved my problem. To cook the sausage, I've been using this hot dog roller, which actually turned out to work pretty well, except over the course of the 8 minutes of this part of the program, the sausage seemed to roll away from where it was set, so I rigged up this piece that sticks into the roller to keep the sausage from rolling away. But once again, another problem is how to get it off of the sausage roller onto the plate. Since I couldn't reach it again with the gripper, I had to make another tool that had a fork on it, so I could fork it and then put it on the plate. I took another piece of aluminum profile about the same size as the egg manipulator and attached a fork to it. And to make it easier, I also sharpened the fork so it stabs better. Now this doesn't sit flat because its center of balance is over the base of the aluminum extrusion, so it kind of falls over. I 3D printed the stand real quick just to prop it up and put a slope on it so it's adjustable. Some magnets to hold them down to the base, and they worked really well. Only at this point, Robot 1 was so busy that there was no travel room left to put this tool anywhere. If only I had some way to change out the egg grabbing tool with the fork tool at some point in the program when the robot wasn't busy with any tools. If only I had a smaller robot that its only job was to swap the tools out in a certain part of the program. And then I remembered I have the mirror bot, which I have left over from some previous projects. And through some adjustments with the tools, it worked really well at swapping out the tools and really gave me the least amount of problems throughout this project and worked pretty reliably. But I've struggled with this before in the past, and there's a way around it, but I never really found anything as to how to get the mirror bot to talk to an Arduino. I have two control systems running next to each other for this project. One is the Arduino that controls axis 5 and 6 and the gripper and all the servos on the system, as well as a relay that controls the egg cooker and all that sort of stuff. And then the robot arms have their own control system that's running a program that's talking to the Arduino back and forth through ready signals. So the Arduino is kind of keeping pace of the program and telling things when to operate and turn on. So I need the Arduino to tell the MiroBot when to swap the tools out. Only I couldn't figure out how to do this through a normal input, so I had to come up with something creative. So what I ended up doing was pulling up the MiroBot program on a laptop. Then I took an old junky computer mouse, took the circuit board out, desoldered the left click button, and soldered in a relay that the Arduino is controlling, then hovered the modified mouse over the run button on the laptop. So whenever the Arduino closed and opened the relay, it would act as a mouse click and it would click run on the laptop. Seems like a pretty overcomplicated solution, but it worked really well, and the Arduino is talking to the MiroBot. Next was the coffee. The obvious thing to do here was to use a Keurig, where the robot could simply put in a K-cup and then hit brew. Only this was a lot more complicated for me, because the robot did not have enough reach to reach over the coffee maker to open and close the K-cup holder. I had to build this elaborate latching system to allow the robot to open and close the K-cup holder. The plan was to have the robot hit it hard enough on the handle so it would open all the way on its own, and then close it through a series of motions where it pushed the bottom part in, pushed down on a latch that I attached on the side, and then turn around and hit the brew button. Only this didn't work too well. I couldn't get the holder to open up the same way every time, probably due to the inconsistency and the rigidity of my attachment on the arm, and I tried a lot to dial this in to work every time, but just couldn't make it consistent enough. So I put this rubber band in the perfect spot to open the lid the rest of the way after the robot started to open it, and this made it a lot more consistent. Though while I was continuing to test these parts of the program, I found a major engineering oversight in my wrist mechanism. The direct drive coupling for Axis 6 was initially 3D printed out of PLA plastic, and it just was not holding up. The stepper motor gets really hot, so it was melting the plastic and warping it. When I pulled it out of the wrist mechanism, it was bent. In fact, it was melted so bad that it didn't even have a grip on the motor shaft, even with the screws tightened all the way down. On top of that, I had consistent issues with the thread inserts getting pulled out every time I crashed it, so I knew I was going to have to do something about this. So I modeled up a very simple part that would grab onto the stepper motor shaft and also have have some threads on the side to screw down the gripper. And I machined this out of 1-inch diameter aluminum rod on the manual mill and lathe. And this part never gave me any more problems and stayed super rigid the rest of the course of the project. So that was everything I learned. Now here are all my learning moments. So that's how you make a fully automatic breakfast maker out of old industrial robot arms. If you haven't seen the video of the whole system working, that will be linked here and also in the description, as well as a uncut version to see the whole thing operating automatically by itself. Some of the CAD will be posted on my GitHub as linked in the description. And if you're curious as to how I got these industrial robot arms, it's a very interesting story. I definitely suggest watching that. That'll also be linked in the description. I have much more expensive, much bigger projects coming up, so you should subscribe so you don't miss it, and thanks for watching.